This section of the book, in my opinion, covers three different things. First, we're going to talk about functions. That's a really commonly used word in math, but you're going to see in a little bit how really it's a word that's sort of misused because, well, I'll explain in a minute. Functions, and then what we call one-to-one functions, and then finally inverse functions. Now, I'm just warning you, this is the kind of material where it's a lot of like definitions and terms, not as much working out math problems. So, not horribly difficult to understand, but more of information than actually like solving problems, solving equations, although there is some toward the end where we more do sort of math kinds of stuff. The word function in math is really thrown around a lot, and unfortunately it's sort of a problem because function actually literally has a definite type of meaning in math, but because it gets used so much, in other words, function, a lot of times we use it like equation. Like here's an equation, here's a function, and we just say that. But actually, in the sort of the literal sense, that equation might not actually be a function, although we call it a function, and we have function notation. It's just sort of confusing. Right now, we're going to look at some equations and see if they are in fact an actual function by the definition of a function. As a matter of fact, the word we should use in math instead of function or functions, I think a better word is relationships. In math, a big part of math and algebra, relationships, and by that I mean typically we have the two variables x and y. How are x and y related? That's what a relationship is. Very simply, so here's an equation. This describes how x and y are related. In other words, you choose a number for x, and you add 2, and you get y. Here's another relationship. Y equals 2x squared minus x plus 1. You plug in a number, square it, multiply it by 2, then you subtract the number, then you add 1, you do all that, and you get y. Sometimes you can have it's not even y equals something. You just have x's and y's, some kind of equation. So I call these relationships. These show how x and y are related to each other for these individual equations. Now what happens is you can look at all these different relationships and you can analyze them, and oftentimes those relationships end up being an actual function. Oh, let me, before I do this, let me talk about, so there's different ways in math to express relationships. These are equations. Once again, a relationship tells us how x and y are related, how they're dependent on each other. You know, another way in math that we learned about math relationships are ordered pairs. In other words, remember an ordered pair, x is the first number, y is the second number. So if I have a group of ordered pairs here, this actually describes a relationship between x and y. Because what it says is, when x is 1, y is 2. This ordered pair says, when x is 2, y is 4. This ordered pair says, when x is 3, y is 5. Now what's interesting, with an equation describes an infinite number of ways to relate x and y. Because with this equation, y equals x plus 2, I can set x equal to 0, x equal to 1, x equal to 4, x equal to 9, x equal to minus 10. I can choose whatever number I want for x. It's almost like it's unlimited. Where an ordered pair, it's very specific. Matter of fact, if I call this I'll call it f of x, although I'm not saying this is a function. This is just f of x. It may or may not be a function. A lot of times, you know, up here, we like to write f of x equals x plus 2, replace fx with y. Here, we say f of x is this whole relationship, which basically, I shouldn't do that probably. That may be confusing. Let's call it like set A, maybe. So A is this relationship. X can either be 1, X can be 2, or X can be 3. That's it. Those are the only possible values of X for this relationship. When I have an equation, X can be anything. But once again, a relationship just describes how x and y are related. Now here, I only have 3 possible x's, so only 3 sort of little relationships here. Now the last one that also describes a relationship is a graph. Because what's a graph? A graph is, you have the x-axis and the y-axis. This line represents a relationship between x and y. In other words, if I ask you what is y when x is 1, well, you go to x equals 1, you go up to the graph, and you see that point right there is 1, 5. When x is 1, y is 5. If I said, what about when x is negative 2? Well, when x is negative 2, y is 1. So the graph is sort of like the equation. I can choose all kinds of different values of x and go find the y. So it's almost like equations and graphs are oftentimes sort of unlimited in the x's you can choose, where the ordered pair, it's very limited. So as we describe functions, one-on-one functions, and inverse functions, these are the 3 different ways we're going to talk about it, 3 kinds of relationships. Typically we'll do ordered pairs first, then graphs, then equations. All right, so now that we have an idea about relationships, anytime we're given a relationship, say we're given this equation, say we're given this set of ordered pairs, say we're given this graph, any kind of relationship, the question is that relationship a function? And in a minute, I'm going to tell you how to determine whether it's a function. What happens if it's not a function? What do we call that? Well, there's actually no fancy word. It's just not a function. So for every mathematical relationship where x and y are related, we can determine, is it an actual function or is it not a function? So let's go down one at a time, these three kinds of relationships, and let me tell you how we can decide whether it's a function or not. So let's look first. If you're given a set or a bunch of ordered pairs and they say, is this relationship a function? You simply ask one question. All you do is look at all the different values of x in your ordered pair. You don't even care about the value of the y's. You only look at the x's. And you ask yourself the question, does x ever repeat? Do you have two ordered pairs at least with the same value of x? Now if the answer is no, you actually have a function. So a function is where you have ordered pairs where the x's do not repeat. Every x is unique in a function. If you have some ordered pairs and you go check all your x's and all of a sudden you have x's repeating, not a function. So for example, if we look at this group of ordered pairs, would this be a function? You simply go look at x. X is 1, x is 2, x is 3. Since the x's are all different, this is a function. Okay, let me do another one. How about, so if I start with 3 ordered pairs, would this be a function? You simply look at the x's. 0, 1, 2, -1. Are any of them the same? No. So these 4 ordered pairs would be a function. However, well, what's interesting is, but look here. My y's repeat. Look at the y's. 1, 1, 4, 3. But you know what? I don't care about the y's. In terms of being a function, all that matters are the x's. And the x's are 0, 1, 2, -1. This is a function. However, just for fun, what if I added a 5th ordered pair, and then I said, is this a function? Once again, you just look at your x's. 0, 1, 2, -1, 1. Then I notice this ordered pair and the second ordered pair, x is 1 for both. So this now is not a function. Because x gets repeated, it's not a function. Now what's interesting, just real quick, maybe you've never thought about this before. You know the whole idea of domain and range. Domain, we call all the possible values of x, and range are the possible values of y. So that's why we've got this here. What if you were asked, what's the domain of this relationship? Let's go ahead, for now, let's eliminate this. So now we do have a function. They say, what's the domain of this function? Well, in this case, the domain is all the possible values of x, but we have a very, very limited world. Matter of fact, we only have 4 values for x. So you would say the domain is 0, 1, 2, -1, right? I just simply list all the x's. That's the domain when you have ordered pairs. And the range are all the possible values of y. You simply list all the values of y in your ordered pairs. You've got 1. However, I just listed 1. I don't need to list it again. Then 4, and then 3. So I don't know if you've ever been shown that before, but that's how you find the domain and range when you have ordered pairs. All right, so determining whether ordered pairs are a function, pretty straightforward. How about when you have a graph? This is maybe the easiest thing of all. We're going to do a little test on the graph. It's called the vertical line test. So the key is you're given a graph. And you're going to go every place and any place on this graph, and in your mind, or you can even do it on your page, you're going to start drawing vertical lines. And here's what you're looking for. You're trying to see if I can draw a vertical line that crosses the graph in at least 2 places, it's not a function. Let me write that down. If vertical line crosses graph twice, not a function. So if I think about this one here, I'll actually draw the lines. I start over here. There's a vertical line. It crosses it once. Hopefully you can see quickly how I can draw all kinds of vertical lines. I'm never going to cross this graph twice. So you end up saying this graph is a function. Let's look at another graph. And just out of interest, and we have talked about this before, domain and range of graphs, right? The domain, what's the smallest value of x for this graph? -infinity. What's the largest value of x? Infinity. Domain is -infinity, infinity. What's the range? The range is the smallest value of y, largest value, right? However, let's look at whether this is a function or not. What if we had sort of a sideways parabola? So we're given this relationship, this graph, and we're asked, is it a function? All right, vertical line test. Can I draw a vertical line that crosses the graph twice? I just did. So this graph is not a function. And actually, you know what? If you think about it, we talked about ordered pairs. We said x cannot repeat. What's going on here? Think about this. Think about this point. Maybe that point is like x is 3, y is 5, and this point here, x is 3, and y is -2. Here are 2 points on the graph. These are like ordered pairs. And look at these ordered pairs. They have the same value of x. It's almost like we did the ordered pair check. We have x's repeating, which we can't have. So when you have a graph, very easy to check. So we've looked at how do we check ordered pairs if they're a function, how do we check graphs if they're a function. The last one is equations, which is actually can be the trickiest sometimes. You sort of have to ask yourself the question, and it's not always obvious, but usually it's not too hard. So here's the idea. You're given some kind of equation, and you're asked, is it a function? And here's what you really need to ask yourself. Or I'll put it this way. You have a function if every value of x gives only one, that's the key, value of y. Let me tell you now, most equations typically end up being functions. It's sort of rare to have an equation that's not a function. Now here's an example of one. How about this relationship? If I stick if I say, hey, when y is 2, what is x? I could write it like an ordered pair, right? 4, 2. Plug in a 4 for x, 2 for y. What happens when I plug in negative 2 for y? What is x? X is 4. So for this one, so from this equation, I've come up with the two ordered pairs, but look what has happened. When x is 4, y is 2. When x is 4 again, y is negative 2. Look what I've said here. You have a function if every value of x gives only one value of y. Here's a case where when x is 4, y can be 2 or y can be negative 2. Here's one value of x that gives two values of y. So this right here is not a function. However, if we were to do the same thing here, every value of x I picked, if I set x equal to 4, there's only going to be one y, one number for y. If I set x equal to negative 3, there's only going to be one value of y. So just rule of thumb is most equations are functions. I know I'm being a little wishy-washy here, but equations can be a little tricky. So that's how you tell whether relationships are actually functions. That's why not all relationships, I mean this relationship here, it's not a function. I mean it's a graph and it describes how x and y are related, but it's actually not the definition of a function. And that's why I say in math we throw around the word function a lot for things that probably actually aren't even really functions. So that's functions. Okay, now say you're given a relationship and you go and look and you decide, yes, it is a function. Now there's a second question you're oftentimes asked in math. And you're asked, okay, you've shown us a function, but is it a one-to-one function? So now that we have a bunch of functions, we can break them down. Some functions are called one-to-one functions. So what do you think we call the functions that are not one-to-one? No fancy math words that I know of. We just call it not one-to-one. So once again, the easiest thing now is, let's go ahead and let me tell you how you check. If you have a function of ordered pairs, if you have a graph that's a function, if you have a equation that's a function, how do you check to see whether it's a one-to-one function? So you can have functions, but the next step up, is it a one-to-one function? Now the thing is, it's very similar to how we check for just a function. So first, for ordered pairs, remember, for a function we ask the question, do x's repeat? And if they do not repeat, we have a function. For ordered pairs, you're interested to know, the question is, does y repeat? So in a sense, you know what we're doing, one-to-one function? We're really, because it's a function, we've checked if x repeats, and now one-to-one, does y repeat? So really, one-to-one function check is all the x's and the y's have to be unique. So really, I could, as sort of a conclusion, for ordered pairs, I could say basically no repeating x's or y's for a one-to-one function. So for example, first question, here are four ordered pairs. Are they a function? Check the x's. 1, 2, 3, 4. Yes, it's a function. But now, is it a one-to-one function? So now I check the y's. 0, 5, 0, negative 1. As it stands right now, this is a function, but not a one-to-one function. However, because why is it? Because I got a 0 here and a 0 here for y. However, what if I make it like this? Is it a function? 1, 2, 3, 4. Yes, it's a function. Is it a one-to-one function? 10, 5, 0, negative 1. At this point, we would say it is also a one-to-one function. How about a graph? Remember function. We did the vertical line test. Remember, we would take our graph and we would start drawing or looking at vertical lines. And if we ever could find a vertical line that crossed the graph twice, and it would not be a function. So what do you think we do with one-to-one function? Same idea, which is nice. We actually do a horizontal line test. And the same rules apply. Horizontal line test, if you can draw a horizontal line that crosses the graph twice, then it is not a one-to-one function. let's just look at some examples. Say we have sort of a normal upward parabola. Is this a function? What do you think? How do we check for a function? Vertical line test. Are there any vertical lines that would cross this graph twice? No. So it is a function. Now, is it a one-to-one function? Horizontal line test. Oh, there's a horizontal line that actually crosses the graph twice. So it is not a one-to-one function. It is a function, but it's not a one-to-one function. How about is this graph a function? Yes. Is it a one-to-one function? Yes, it is. Now the last thing to check is equations and equations. Remember, in fact, I have it written down here. You have an equation, you have this idea. Every value of x can only produce one y. That makes it a function. Well, now you flip it around. Every value of y now you say, basically, I can't have one y give two different x's. You just flip the definition of a function. Once again, equations are a little interesting. So now, beginning this little talk, I said there are 3 topics to be covered. Here's my page. Functions, which we've talked about and defined. We've now talked about and defined and told how to check one-to-one functions. And the last one's inverse functions. So this is pretty involved, so I'm going to go ahead and stop this video, and then we'll start again and we'll cover inverse functions.